The question says that a project is to be completed by Alan and Ben. If Alan works on the first day, Ben works on the second day, and they work on alternate days, the number of days required to complete the project is a whole number. If Ben works on the first day, Alan works on the second day, and they work on alternate day, they completed the project half a day earlier. If both of them works together every day since the first day, the project can be completed in 1/3 days. How many days does it require for Ben to complete the project alone? Now, if we observe the question here, there are three situations. Okay, situation one says that okay, the project started with Alan, right? So Alan works on the first day, and Ben continued to work on second day. So then followed by Alan, Ben again. Okay, so the number of days required to complete this project is a whole number. Now the whole number means that, all right, they require maybe 7 days or 10 days to complete the project. Okay, but it is not 6.5 days or 1/4 days. No, right? It's not a fraction, but it's a whole number. So this is for situation one. Now the situation two here says that the project started with Ben, right? And Alan continued to work on second day, then Ben, Alan again. So for situation two, they complete the project half a day earlier. So the time taken is lesser. Okay, for third situation here, Alan and Ben, they work together. So they take 3 full days, 3 full days, and 1/3 days, okay, to complete the project. Okay, so now what do we want to find here? We want to find how many days does it require for Ben to complete the project alone. So if Ben is to complete the project alone, how many days does Ben take? Now, to solve this question, we need to understand a concept. Now, for example, if Alan can complete the project in 10 days, okay, so this will be number of days. So Alan complete the project in 10 days. So this is the project, one project. Now, so we say, all right, for one day, okay, we can say that for one day, Alan is going to complete 1/10 of the project. Okay, so one day, 1/10 of the project. So for 10 days, so Alan is going to complete one project. So you can see here we have number of days, 10 days, multiply, okay, let's say this is the efficiency, right? The efficiency is 1/10 in one day. Okay, Alan is going to complete 1/10 of the project in one day. So when we multiply, we get 1. Okay, the 1 here represent one full project. Okay, so we have number of days, multiply the efficiency, and this is equivalent to one project here. Okay, now this concept is very important when we solve this question here. Now back to our question here. Okay, so when we analyze the problem here, we can see that the work done for the first 2 days, okay, so this is day one, and day two. Now for the first 2 days, the work done for situation one and the work done for situation two, they are actually equivalent. Okay, so A work for the first day, B for the second day. This is B for the first day, A for the second day. So we know that they complete the same amount of work. Okay, this goes to another 2 days. Okay, now the question say for situation 1, number of days to complete the project is a whole number. And for situation 2, half day earlier. So with this information, now we know that it's supposed to be, right, A is going to complete the project because it cannot be B, right? If B, 2 days, so means that situation A and situation 2, they are actually the same, okay, same amount of work done. So A is going to complete the work, right? The last person to complete the work for situation 1. And for situation 2 here, B is the last person to complete the work and it takes half day here. Okay, half day to complete the work. Now, if we observe the third situation here, now we can see the work done in 1 day for situation 3 is actually the work done in 2 days for situation 1 and 2. Okay, for situation 3, 1 day, A and B, they work together. So this is equivalent to this one. Okay, 2 days, A and B work together. So we say that AB, right, is equals to 2 days work. Okay, for 1 day in situation 3 is 2 days work in situation 1 and 2. Okay, so now we can actually convert the information. All right, so this is 2 days here. So the second day, another 2 days here. So the third day, all right, it will be another 2 days here. Okay, another 2 days here. So it takes 1/3 days for both of them work together and complete the project. So 3 days, 3 full days, it will be converted to 6 days for situation 1 and 2. And all right, the last one will be, all right, the A, complete the project for situation 1, and B, completed the project for situation 2 using half a day. Okay, now, so from here, now we have a conclusion. How many days does it require for situation 1? Okay, it requires 7 days. Okay, 1, 2, 3, 4, 5, 6, 7, 7 days. So 7 days to complete the project for situation 1. And of course, for situation 2, it will be 6.5 days. Now, however, the question wants us to find out, right, if Ben works alone, how many days does it require to complete the project? Okay, so from here, we actually know that the work done for A, okay, in 1 day is actually half of B. Okay, A take 1 day to complete the project, but B take half a day to complete the project. So half of B is actually equals to 1A. Okay, so remember the B is the efficiency and the A is the efficiency of Alan. Okay, B is the efficiency of Ben. Okay, so half of the efficiency is actually equals to A. Now, so when we substitute this into situation 3 here, we can replace the A with 1/2B. Okay, this A replaced with 1/2B. So for 1 day here, it's going to be half B plus 1B is going to be 3/2B. Okay, because it's half B plus 1B. So 3/2B. So this is the work done in 1 day. So we can put it this way. The work done in 1 day, 3 over 2b, the efficiency, multiply number of days. How many days? 3, 1 over 3 days. Okay, number of days, multiply the efficiency. Now it's equivalent to 1 project. So we are going to solve this. So by solving this one, now we have 10 over 3. All right, 3 times 3, 9, plus 1, 10, times 3b over 2 is equals to 1. Simplify this, we have 5. So it means that, let's continue here, 5 times b is equals to 1. Now remember before this we say that, okay, the b is the efficiency of Ben, all right, and the 1 is the project. So what happened to this 5? This 5 represent number of days. Okay, the 5 here represent number of days, all right, and the b is the efficiency of Ben, and the 1 is the project. So we have 5 days here. Okay, so this represent number of days. So for B, it takes 5 days to complete the project. Now, alternately, we can also calculate this way. So the efficiency of B is 1 over 5. Okay, the efficiency of Ben is 1 over 5. It means that for 1 day, Ben is going to complete 1 over 5 of the project for 1 day. Okay, B is going to complete 1 over 5 of the project. So if B is going to complete 1 over 5 of the project in 1 day, so so it takes 5 days for Ben to complete the whole project. Okay, so this will be the solution of the problem.